So they've randomly selected 42 non-returning seniors. What does that mean?
So what should I do for the week?
Right? So, yes? So they've randomly selected 42 people who would be seniors who are not coming back. And then 48 people who are coming back.
Wait, what kind of senior
Okay. And then they rated themselves on personal contact. What do you think that means? Right. So what they're measuring here is like how much. See, like a big problem in college is dropouts. Okay, big problem. Okay, way bigger than in high school. Okay, and trying to figure out why dropout rates are so high in college is a big issue. One of the reasons is money. I mean, that's probably the biggest reason. But I think what they're trying to get at here is, are there other reasons in this school that's causing people to drop out? So one way to do that is to take a random sample of people who did drop out and a random sample of people who didn't, and look to see if there are differences in those two groups, right? Okay? So when they say personal contact, they mean, did anybody in this university make personal contact? Like, do you know, the way to ask these kind of questions is like, is there a faculty member who knows you? Right? That's a good way to kind of ask this question. So they're asking to rank how much contact they've had with the university, personal contact. And it looks like on a scale of maybe 1 to 5 or something. Maybe 0 to 5. And then what about campus involvement? What are they asking you there?
What do you do?
Right. Do you participate in clubs and things? That's what they're asking. Are you involved in the campus? Okay? Because if we could do a study and convince ourselves that students who drop out are much less involved in the campus, maybe we could make an effort to get people more involved in the campus, right? That's the idea. Okay? So, is this means or proportions? MS. Means or proportions? Everyone agree? Okay, so Z or T? T. Okay? Is it one mean or is it two?
Two.
One mean or two? Two. Now, there's going to be a second question for two means. Are the two samples independent of each other? Of each other. Because if they're not independent of each other, there's going to be a different test. Okay, are these two samples independent of each other? Yes, right? They're two separate random samples. So this test is called a two-sample t-test, sometimes called a two-independent sample t-test. Okay, so it's not an SR. Oh, first of all, did she have the nulls right? Yes or no? Is she using parameters? Is she using parameters? Yes, good job. Does she have an equals in the null? Yes, good job. Does she have the right alternative? No, not good job. Well, what's wrong? Right, read the question. Do students who don't return to college have a lower mean personal contact list? So what's D and G? Okay, it's not about whether they graduate. So let's call them non-returning and returning. Okay. So they wanted to know whether non-returning have lower. So that should be a good. We agree? Good. All right. First assumption. She said a simple random sample. Is that what we want here? We want two independent random samples. Okay? So there were two independent random samples. So what? Mahana, so what? You have to think this through here for the right notation. Give it a shot, and we'll see if you're right. I know it is pretty hard. It's pretty hard to think this through. What you're trying to say. To do this, you have to think about what the sampling distribution is. What is the sampling distribution of? Not means, quite, but what? Difference of means. What would we call each one of those difference of means? N bar minus R bar, if we're using that notation there. So the center of that sampling distribution should be called mu sub N bar minus R bar, right? That's the center of the sampling distribution. And if there's no bias in our selection, then that should equal the difference of the parameters, right? This sentence should always be the mean of the sampling distribution equals the actual parameter. So how should she write the parameter? Somebody besides Evers. How should we write the parameter? What are you saying, Ethan? The middle of the sampling distribution, which is what she has there, should equal what? Ruh-roh. What's the parameter? Right? So look, when we're in one sample, right, we say something like this. Mu p hat equals p, right? Or mu x bar equals what? Equals what? Mu. The middle of the sampling distribution equals the actual parameter. The middle of the sampling distribution equals the parameter. She has the middle of a sampling distribution. X bar 1 minus x bar 2. What should that equal? That's right. This is what that assumption of no bias is. The middle of the sampling distribution equals the difference of the parameters here. Yes?
Can you also just assume that like mu x bar 1 equals mu 1 and mu x bar 2 equals mu 2?
That's the same thing.
But
Yeah,
like,
yeah,
line equals
yeah.
out.
You could say it that way too. You could say therefore this, if both of these two things are true, that would also be fine. Those are equivalent. Yeah. All right. Second one. So now we need to know, not that we've already talked about the samples being independent of each other, but now what?
They have to be independent, like among themselves.
Right, within each group they need to be independent. The 10% condition needs to be met. Does anybody have any issue with any of that? Yes? Okay, but they took random samples here. Right, so we would have no reason to believe that you and your friends would be more likely to be in this sample. They did tell us that, right? They've taken 2 random samples, right? Mm-hmm. All right, so what? Everybody think now. So what? Who's got it? Mia, what is it? So what? Well, is it about the means or the standard deviations? The standard deviation. Of what? What are we trying to assume about it? The standard deviation of what?
Each of the 7
Right? We're going to draw a picture in a minute of a what? Of a
This is for-
distribution. So we need the standard deviation of that distribution. What should I call this? She's not quite right there. Now she's right. Mia, do you see? This is this. What does that equal? Well, you could have two alternatives. I don't know, we never did this test before. Or, let me think about it, because I know how to do this. What does this equal? Come on, what does this equal?
Sigma over
Sigma of the population over
root n.
root n.
You approximate sigma of the population.
Yeah, but I'm just saying, what's the formula? We'll approximate it in a minute, because we'll have to, but that doesn't change what the formula is. Okay? And then this is the same thing. So what's the formula here? You're just subtracting the two, right? So what's the formula? Good. Do we add standard deviations?
Add variance.
We add variances, right? So here's our key formula for the two proportion z-test. And can you simplify that a little bit? Square root of the variance of 1 over n, 1, right? So here's our key formula. But again, if you're memorizing these as separate formulas, you're not learning it very well, and I'm not teaching it very well. Okay, 3. Our n is the n's big enough to assume normality. So what are you going to have to check? Are NPs and NQs, are all those bigger than 10? That's a yes or no question. Well, I don't really know P
P?
or Q.
Yeah.
There are no P's. What are we talking about? What's that guy talking about?
What are you talking about?
That's proportions. This is means,
We look at the picture.
right? So what we have to decide, do we have big, medium, or small sample sizes? What do we have here?
Medium.
Medium?
What does
I
your
mean,
book
it's-
say?
it's
40 or
big.
bigger?
Yeah, the book said 40.
I said 30 in class yesterday, but then they told me that the book has 40. That's who's done chapter 23? Does he say 30 or 40?
Yours
All right.
is 40.
40 or 50? Okay. Okay. Again, these are all arbitrary. What are our sample sizes here?
42, 48.
All right, let's say we're good to go. Okay, so our two n's are big enough to use a t-test.